Welcome to Civil Engineering Knowledge Channel. So today we will have a small topic of understanding, but if you consider in civil engineering, this is very one of the most important basic topic. Okay, so that is nothing but the concept of tension and compression zone. For example, so if we consider a beam, okay, where Ra and Rb are the support reactions, P kilonewton is nothing but the load that is applied on the beam. So when the load is applied on the beam, so the bending action of the beam will take place in this particular manner, where on the top there is a action of compression zone which is created, and at the bottom tension is created. So we always as we are always aware that we always run away from the tension. So the forces at the bottom which are moving away, okay, those are the tension zone, and on the top compression, the word itself says there is a compress of the forces or the top materials that takes place on top of the beam. Okay, so this particular center, that is a neutral axis, and what will be the depth of this particular length if you consider, that is d by 2. For full it is d, and for half of its length, that is d by 2. So this is how we call the cracks on the beam. So at the end of the beam, those are the shear crackings, and at the center, okay, near to tension zone, the cracking that takes place on the beam is flexural cracking. So as we all aware that concrete is strong in compression, okay, but weak in tensions. So whenever concrete is weak in tension, how to overcome that? By reinforcing the concrete. How do we reinforce? By providing the steel reinforcement. So since at the bottom of the beam there is a tension zone, you should always provide steel at the tension zone. So we are, as we are aware that for example in the live site or the construction, when we just go, we can just observe that always at the corners of the slab or something. For example, if this is a slab, okay, at the corners of the slab there is a more steel that they are provided, where in the center the provision of the steel is less. You can just observe this in the live site. Okay, so this is why the steels are provided more at the support section. That is because tension zone is higher at the supports, and at the center that is weak in compressions. So that is why the steel is provided less, okay, where the concrete will help to hold the steel in a better manner. So you can just have an understanding here. So concrete may be strong in compression, however it is weak in tension. Hence steel bars are provided at the bottom zone so that it greatly reinforce and strengthen the concrete beam. So if I just want to say a logical example, okay, how steel is important for the concrete. So if you just see the highest yield dia of the steel, for example, the 32 diameter steel bar that have higher tensile strength of 500 Newton mm square, so that 3000 kg per elephant, okay, if you consider that is almost 10 numbers, so it can hold up to 10 numbers of the weight, which means the tension, I mean, that is the reason why the steel bars are provided wherever in the beams or columns, wherever it is weak in tension. So this is a simple concept that I wanted to explain today, so that in future videos I can just explain more on the structures. If you have any clarifications, you can put your comments on comment section. At most possible, I'll try to reply on that. Thank you.